Hello. We're doing a special video today where we're going to do something quite useless. We are going to write a simple Macintosh program. And to help me with this, because Google isn't really very forthcoming with old Macintosh programming results these days, I found my old programming book. It's in German, so it's not as if I'm going to be reading from it or something. But it's called Macintosh Programmieren in C. So programming the Macintosh in C. It's not a C class, but rather it's a class in programming the Macintosh when you already know C. It was written by a guy named Carsten Brinkschulte. And yeah, it was one of the things that got me going back on the old Macintosh operating system. That was, I think, in the System 7 days. And the book has nice printed pictures and everything, and illustrates a lot of the stuff I'm going to be explaining. I'm not going to go along with this book because it's not really a code-along book, and I'm just going to try to do quick explanations myself. It even prints some of the data structures that you would find in the documentation, because, as I said, back then it wasn't that easy to actually get documentation, because those were phone book-sized books. So, and they cost, I think one was 50 Deutschmarks for me. So, you know, today that would be probably roughly equivalent to 50 euros. But you have to keep in mind that I was a student in high school at the time, so I didn't really make much money or anything. But anyway, they explain a lot of things, like here is the coordinate system and how multiple displays are handled. So it really goes nicely in depth. So that's something where I will be able to peek if I need to. And anyway, I just wanted to give you something a little old and authentic to look at, because I think that always kind of comes across pretty well. But let's do a proper demo. I have an emulator set up, so I'm sitting in front of a regular PC, not original hardware, just because that makes it easier to capture it, and also because original hardware takes some effort to keep alive, because of, you know, like bursting capacitors and things like that want to be replaced. We will be using the programming environment MetroWorks CodeWarrior 10 Gold, which was the first one I ever used, I think. Or did I use CodeWarrior 8? It's hard to remember because they went through the numbers twice. They did CodeWarrior and went to, I don't know, 12 or something like that, I think. And then they restarted the numbering with CodeWarrior Pro 1, 2, 3, 4, 8. So I'm never quite sure which was the lowest number I used, because I keep forgetting which one was Pro and which one was non-Pro. But anyway, this is installed from one of my old discs, so this is definitely one I had. So yeah, and CodeWarrior is a fairly modern development environment. You'll find it fairly similar to what people still use today. Just, you know, a bit older. Let's close these windows, we don't need them. And wait, Can't I? Yeah, I can tear it off. All right, let's keep that here. It's just easier to see which program I'm switching to. That's a nice new macOS 9 feature, so to say. In older operating system versions, you at best had this menu. At worst, you had just an icon for the current program in the menu bar, and when you clicked it, it switched to the next program, so it just rotated through, kind of like Alt-Tab would do today. Anyway, so when CodeWarrior starts, you get its menu bar on a Mac, and you get this little toolbar window that actually shows some help in a very Windows-like style. The Macintosh native way would be to use show balloons, which this window doesn't even use, but like if I point here, for example, it tells me with the balloon what the thing I'm pointing at, in this case the zoom box, is. To change the size of the window, quickly click here. Clicking once sizes the window so that all of its contents are visible if possible. Clicking it again returns the window to its original size. Which, yeah, sort of even applies to this window. Although this is not a classically resizable window. Anyway, so let's turn off these balloons again. What we want to do is we want to create a new project. Alright, we want a macOS program. Yes, I'm going to be writing in C, C++. The Macintosh traditionally was a Pascal machine. And that made it a little difficult because all the documentation was written for Pascal. So if you were programming a Mac at that time, you had to be pretty good at translating between C and Pascal syntax to be able to make some sense of the documentation. PowerPlant is a CodeWarrior specific thing. That was an application framework to which they included the source code that made development a lot easier and contained a lot of advanced functionality, like, and it was also a C++ framework. And the classic macOS APIs were actually plain C. So we're going to create a basic Toolbox application, PowerPC. 68K is the original Macintosh, was a Motorola 68000 CPU. That's why 68K is still an option, but by the time macOS 9 came out, people had pretty much switched to PowerPC CPUs, which, if you remember, were the CPUs that were used at the start of macOS 10 as well. And then some at 10, I think it is 10.4.4 or something like that. Apple actually switched to Intel CPUs, and of course now we've just switched most of the product line to M1, so basically the iPhone ARM CPUs, which are actually kind of similar to PowerPC CPUs. They're both RISC architecture CPUs. So yeah, so we've had a couple of CPU switches at Apple since they came out, 68K to PowerPC to Intel to ARM M1, or Apple Silicon, or whatever you want to call it. So, wow, 4 architectures so far. So we're gonna pick PowerPC just because that's what this emulator actually emulates. We could do 68K because macOS 9 actually included a 68K emulator, but, you know, why make it more difficult? Okay, so we're creating a new project. What are we gonna call this? Let's just call it Stream App for now, or yeah, let's use that name. Who cares? Okay, so what CodeWarrior does is it has a project window, which actually contains some example files, and which is kind of like a make file if you're familiar with that, or otherwise, you know, like a Visual Studio solution or something like that. Oh, and I made a mistake. See, already started, already made a mistake. So there's one pitfall that you have if you're using CodeWarrior to compile classic macOS, and that is that in general... Oh, maybe not. Let's just try it, I guess. Let's run this. Do we get a weird error? Yes, we do. Okay. So the default setup for this template is to create the application with the name of the project. Now, if you just name it Stream App, then of course you have a problem, because oh, okay. I just minimized the window on myself, on everything else apparently as well. That's the downside of this emulator. Okay, usually you would press Option M, which is the mu sign, kind of like MetroWorks. But we can just call it PRJ, like project for now. All right, and so, oops. Yeah, it didn't notice that I renamed the file. That's interesting. It really should have done that. Because usually Mac apps do that. Anyway, so the problem is that if you name your project without a file name extension, which is totally normal on a Mac actually, then it will try to create the application with the name Stream App, with the same name as the project. And of course, trying to build that, it will realize, wait, that file is already open and in use and already exists. I can't replace that. And so this first error message can easily be fixed by just naming your application streamapp.mu or streamapp.prj, or if you have a newer version of CodeWarrior, usually you use a Windows-style extension MCP for MetroWorks CodeWarrior project. Anyway, and now if I hit run, which make run, here's the arrow, yeah, then this test app that they built will actually run. You see, it's a very simple app. It shows a window, and it puts little circles that say Bob in it, and as soon as you click anywhere, it terminates. So that's just a quick example. But it already contains like the main parts you need regarding CodeWarrior for a project on classic macOS. Let's go through these. First, it has the main source file, a C source file, that just contains some sample code. So it contains, include statements, constants, and then a few functions that do the actual code for creating a ball, for creating the window, and things like that. That's regular C code. You'll recognize that fairly quickly if you're familiar with C. Then there is an RSRC file. That's a resource file that is edited with ResEdit, which is an application from Apple for editing resources. ResEdit is basically the modern day equivalent to Interface Builder or what is it? XAML, I think, is what Windows uses. So basically, it's your user interface builder, and it's here just so you can put that stuff in there. There's nothing in here right now. We'll do that later. And then there are two sections for libraries. So there are the Mac-specific libraries, and then there are the ANSI-specific libraries. So, of course, ANSI is, standard C. And it actually has the C++ standard library, the C standard library, and something called SU, which is standard input-output user extension or something like that. Basically, that's a framework containing just enough code to start up a Mac application, create a window, and that window can display text and take text input, kind of like a terminal window or something. So it's enough, to do printf and scanf in C. And that's basically what this one is for. So in most native Mac applications, you would probably not need or use that. On the other hand, on modern macOS 10, you're so used to having these calls and using those that I think I'll leave those in there just in case I need to do something quickly and don't want to look up the old Mac-specific way to do it. What are the Mac libraries? Well, first, MWC runtime is the MetroWorks CodeWarrior runtime. Basically, that does stuff like set up global variables and things like that, run initializers in C++ programs, run the @exit functions, things like that. If you forget that, you might get an error like... Oh, wait, I think we can just demo the error. No, I can't.
Uh-oh.
Ah, okay. Let's see. Where's my inspector? Find project settings. Okay. I think I used a newer version the last time I did one of these demos. And now I can't find... Yeah, it doesn't seem as if it has an inspector nor the right-click menu for finding the location on disk of this file. Okay, so I'm not going to delete this because I don't want to search around finding the library again. They're somewhere in the CodeWarrior folder usually. So I guess if we wanted to look... wait, did I put it in data? CodeWarrior here, yeah. And then MetroWorks CodeWarrior. Oops, why is it? See, there's some file view cleanup. sysers apparently. Let's just put that here so it looks halfway tidy. I think it's macOS support, yeah. And there you find the interfaces is the Pascal stuff mostly. as you see, .p files. The headers and libraries are the official stuff that you would use for C. So for example, macOS PPC contains a whole lot of libraries, and MWC, no, oh right, that's macOS. We would need runtime PPC, MWC runtime lib. So that's where it is. So we can actually risk it. Let's delete this. Hello? Okay, maybe I can't delete it. That's interesting.
Uh-oh.
Remove files. Ah, okay. They didn't put it on the delete key. And if I now try to build it, you'll see undefined __ start. So actually what macOS does is when it runs a program, it tries to run the __ start function. Or, well, actually the linker kind of tells it run the start function. And that is actually implemented in the MWC runtime. And that in turn calls main. So main is not actually the main entry point. Then there's interface lib. That's basically a library from Apple that lists all the system APIs that are available. And then there's mathlib that contains, some mathematical functions that you might also use. So those two libraries come from Apple. Whereas the MWC runtime, the ANSI, C and C++ libs, and the SU lib are CodeWarrior specific. Excuse me, it's CodeWarrior specific. One thing. Let's do the following. Let's delete a lot of the stuff here that we won't be using. Okay, so we have the main function. I'll keep part of the initialized function. So that does a bunch of things, like sysenvironments is basically a function where you can query the operating system for some abilities and put up an error message or something, if your program needs a floating point unit and the computer doesn't have one or whatever. That's not really something that we want to do here. The important part, and the part I always forget how to do, is these bunch of calls. These basically initialize, so set up all of the operating system libraries that you would need for a GUI program. Then they initialize the random number generator with the date and time so that you get different random sequences each time. There's an analogous call srand in standard C. And then here they actually create that window. But we've seen that now. We don't really want that. So we'll leave these calls, and the new ball we can delete as well. All right. And what we'll do now is in the main function, we'll try printf. So first, of course, we'll have to include standard.io.h and do our usual hello world. You notice that since the macOS doesn't have a command line, it's a GUI only operating system, the classic macOS, we do not have a return value from main, and more importantly, we don't take any arguments. That's because, you double click it and you launch it. There's no way to specify any arguments. And if there is an error, either your application crashes or something, then you get a crash, or your application itself has to present some user interface. Okay, so let's run this. And now you see, we get something surprisingly good. We get a window named after our application.out that shows hello world. And we get a minimal menu bar which has cut, copy, paste, save, quit, and even print for our output. All of this comes from the Sue library. And yeah, we don't save. So this Sue library does a lot if you want it to. All right. But we don't really want to use that. We don't really want to use the standard library. We want to show you how would one do a normal Mac application. So the first thing is we call this initialize function to set up all the different managers. So for example, init graph initializes QuickDraw, which is all the drawing API, and gives you a cursor. Well, actually the cursor comes with init cursor, but like just gets you, drawing code. Init fonts adds on top of that and adds, font loading, font text rendering. Then init windows initializes the window manager, init menus the menu manager, TE init initializes text edit, init dialogues initializes the dialog manager. And now dialog basically builds on all the previous things. It lets you create windows that contain predefined buttons and text fields. But it's intended mainly for, like modal dialog windows. And then you can also call init cursor, which gives you these mouse cursors. And by the way, if these cursors here look a little weird, that's because of the emulator. Because the emulator tries to use Windows native cursor rendering to show my cursor, and that gets it resized in a weird way. So it would look a little nicer in a native application. All right, so we call initialize. Now we want to, show a window when we start. And now that's really a bit of work usually. But we'll take a shortcut at first and then kind of slowly peel back what we can do here. So the first thing we'll do is we'll go in our Silly Balls resource file and create a new resource. And now we get all these 4-character codes to pick from for standard resource types. And what we want is a DLOG, a dialog. So we create that. It creates a dialog resource with ID number 128 in our file. We can even give that a name. Let's call it main window. And here we now have a window. Now usually, like this is a resizable window, for instance. You can have a resizable window with a zoom box. You can have a non-resizable window with a zoom box. You can have plain rectangular window or a shadowed rectangular window. You can have a desk accessory window, which has these rounded corners everywhere. that's a special kind of old style window that was used in basically simulating multitasking in old System 6 and before, basically. And you can have a modal dialog window. These appearances drawn up here, by the way, are all in System 7 style. And what you see here is actually how it looks in System 9, where you see it's like with a smooth, more 3D border shape. And you can actually... no, I don't see it. Usually you can create a dialog color table to set a background table, but I guess we'll do that in a moment. Then there is the movable modal dialog, which you see on the inside looks like a dialog, but then also has a title bar, and you can set up your own custom ones. So for now, we go with the modal dialog. Color here, custom, and we pick a custom fill color. Adding color to a D-log will create a DCTB resource to store the color information. The DCTB resource will have the same ID as the D-log. Remember to delete this resource if you delete the D-log. Nice. Okay, and so now this you can see the 3D effect a little better because I put a light gray fill into it. Like, most of these other colors don't have an effect in macOS 9. They basically stopped having an effect in System 6 after System 6. Okay, we don't have a close box. Let's click that away for now. And make it not initially visible so that it gets created invisibly and we have to explicitly show it. Or no, actually, let's make it initially visible so we don't have to show it. One less line of code. Okay, and now we can double-click it to edit its dialog item list, which is another resource that is associated with this title ID setting here. So 128 is the number of the resource. Let's put a quit button in there for now. And... oh, let's put an icon in here so we see at least something. Let's say 1, 2, 3, -1, no, 0. 0 is the stop hand. Yeah, I think that looked the nicest. Okay, so we're creating a window with a quit button and a stop sign for now, just so we see something. And as you see, like, the icons can actually have color. That's why I did that. Okay, now you see we have 3 resources. The D-log, which describes the window borders and things like that, and the background color. Then we have the dialog item list, which describes all the controls we want to see in that window. And then we have the dialog color table, which is the actual place where the colors are stored. But usually when you click them, you just get the D-log editor. But they are separate, so if you open using template, for instance, you can see what it actually stores. Basically, it stores one color for each part. So like white, black is most of the colors. And here our window content color is apparently part code 0 with hexadecimal DD for each component. So that's a medium gray. Well, actually a fairly light gray. Okay, so we've created a window like you would do in a modern application. And now we have to load it somehow. So first so window putter is a window. And then we go and say main window equals get new dialog. And it takes the number of the dialog resource to load, which is 128, but it takes something else. So let's jump into the dialogs.h header, which we can do by selecting its name and saying open selection. Now it opens the header where we can see all the constants and things, and find init dialogs is here, get new dialog. So there's often two calls. There's new dialog, which just creates a dialog with you immediately specifying, you know, like what rectangle to use, what title string to use, should it be visible, what border style it should use, whether it should have a close box, and giving it an item list directly. And then there is get new dialog, which actually shows you, actually loads it from a resource. Okay, let's paste this here. And so the dialog ID number is 128. We remember that from our rsrc file. Storage is... So here's the thing. You can provide your own memory. And then the operating system will put the dialog at the start of that memory block. And you can put other stuff after it. It's kind of... It basically lets you simulate subclassing. And so we're not really needing that right now. So we'll just pass null, which tells the operating system to just allocate the memory itself. And then the last one, so window putter and window ref are the same thing. Window ref is a newer name for a window pointer. It's basically the name that they were given for macOS 10 when programmers were encouraged to no longer look at the internals of the window, because, you know, they were completely different under macOS 10. So now we want our window not to be behind some other window, which we could specify here, create this window behind another window, but rather we want it to be the frontmost one, and we do that by saying -1 instead. And so we typecast that to a window pointer, and now we have a dialog. Let's be a little paranoid and say if main window is null, then return. And maybe so I notice if I did a mistake, do a sysbeep. Sysbeep is the error sound, so that's a handy function that you can just call. This number you can basically ignore. I like to write 007 in there, which is a sensible number for the times when it was still used, but now that it just plays a sound, it's no longer needed. So that's usually that would be the duration that the sound should play, because originally the sysbeep was just like a sine wave. And so you said, you know, beep 10/60ths of a second, or in our case 7. You know, 007 looks fun. All right, and now we want to actually run this. So there is a nice function called modal dialog. It's also in dialogs.h. Modal dialog here. And this function basically contains a so-called event loop. So if you remember, if you ever wrote a command line program that was interactive, what you had to do was you had a loop, and it would always go scanf, ask for user input, and then it would process that user input, and then it would loop back. And one of the possible inputs was, the string exit or quit or something. And in that case, you set the Boolean that the loop, it was like while keep running, scanf, process input, And one of the inputs, if it says exit or quit or whatever, then you would just set keep running to false, and that loop would exit. And that's what you call a main event loop. And that's basically what modal dialog does. It runs an event loop for you, so you don't have to write one, which you usually would have to in a Mac application. And it will return whatever button was clicked or so. So let's do short item hit equals 0. I can use 0 here because on macOS, all the indexes coming from Pascal are 1 based. So that means that item hit here, if nothing was clicked, we get 0. But if the first button is clicked, we actually get 1. So we pass a pointer to item hit. And now what is this modal filter UPP? Again, that's a modern name. It's modal filter universal proc pointer. And a proc pointer is a function pointer. Again, the name kind of comes from Pascal. So you can give it a function there that gets past any events that arrive, and then you can either process them or you can say, modal dialog, you handle them. Again, we don't need one right now, so we'll just pass null. And of course, we should do maybe a loop so that if something gets clicked that we don't want to terminate the app, then we can just say while item hit not 1, because 1 is our quit button. All right. And so this will keep going until the quit button is actually hit. So kind of a loop around the loop. But, if you just move the mouse or whatever, this will actually run an event loop and, like change the cursor and things. So modal dialog is a really nice thing to have. Okay, and when we want to terminate, let's be nice and clean up memory. Dispose dialog. Main window. That should really be all we need. And I guess we don't need standard input-output anymore. So let's run this and see what happens. And you see, we get a dialog window. This is a modal dialog. We get the icon. We get the color. We get a quit button. And when we hit quit, it actually terminates. Now, if we run this again, if we click somewhere outside, you see it's a system modal dialog. It doesn't let you do anything else. But, it's a good start. We can do simple example programs this way. Also, if you hit the return key, it actually triggers the quit button, so that's nice. Okay, so this is basically the easiest way. Like, I know I spent like an hour explaining all these stuff, but you know, in the end, this is the simplest way to get an application on classic macOS if you just want to play around with some of the system API. You don't actually have to write all these event loops and things like that. And you can, you know, use the GUI editor here. We can actually directly open the dialog item list. And, you know, we can add another button here and call it, I don't know, say hello. It's a bit hard to click because the hotspot in the emulator is not correct. Let's just do it right. 329. $59 looks good. So that's an emulator only problem that I had there. So, now I remember, I don't think I have a drawing application here. Oh, I have HyperCard. I guess that works. You know, usually you would have a outline around the quit button to indicate that that can be hit by the return key. Now, in macOS 9, there's actually newer API that you could use to actually get the button to draw like a fancy 3D border around it. But I want to use the older API for now, just to show you how that works. So, let's see, 93 and 213, so that's 20 pixels high, and left 65 to 23. That's 40. Let's go to 5 here so it's easier to do the math. Oh, that's the quit button. Oh yeah, let's do it anyway. Alright, 65 to 25. That means 60 pixels wide and 20 pixels high. Okay. So let's use HyperCard as our drawing application. This is a bit overkill because HyperCard is basically a development environment by itself. But, you know, it's what I have in the emulator right now. Okay, let's create a new button there just so we have something to see. Make it standard. And set, what was it? 60 and height to 20. All right, and now let's use the round rectangle tool and the line size, and we want 3 pixels at 1 pixel distance. Alright, that's a bit misplaced, but should be correct. Yeah. So that's how a default button would usually look. Let's see if we can copy graphics between applications, because I just realized that I think the clipboard in the emulator might be broken. So let's see what happens if we try to paste this. No, it actually didn't copy it. Huh. I'm having a little bit of a problem. Okay, then I guess I can't demo this to you. Well, I guess we can do it a different way. Okay, second attempt. What we'll do now is we'll create a so-called user item. A user item is basically just a box that doesn't do anything. And our application can make it do something. So that's 1, 2, 3, 4 is the user item. All right. Get rid of HyperCard again. Okay. And so how do we do this? Well, first, oh wait, dialogues.h modal filter, that's the argument to, for example, modal dialog. There's even a standard filter proc. That's the one that you get if you don't supply your own. And here is the prototype for the standard filter proc, which is the one we want to use here. So we define let's make this with the more modern style, because I've finally gotten used to it and don't want to change right now. Okay, so first, let's give it a name, like stream, no, let's call it dialog filter, and just pass this instead of null. And now, how do we implement user items? That might be a good opportunity to check out the books. Let me see. Union update events, no. I actually don't know. Do I have? I have on Windows somewhere Apple's documentation. Let me just search for that for a moment. That's the inside Macintosh CD. Here is how I converted them to PDF. And that's Macintosh Toolbox Essentials is the right book. You're not seeing that because that's happening outside the emulator. let's see. So the thing is, modal dialog does a lot of stuff for us right now. So that's why I'm going to make this procedure, and later we can always write our own version. Okay. Oh, to draw your own application-defined item in a dialog box, provide a draw procedure that takes two parameters, a window pointer to the dialog box and an item number from the dialog's item list resource. For example, okay, and that's in Pascal. But okay, we don't actually need the filter yet. Let me just put these windows up next to each other for me. Set D item. Let's see. Let's search here, because there should be this item proc somewhere. Yes, yes, yes. Seen all that. Modal filter. User item proc pointer here. That's how we want to implement it. Okay. Oh, we actually called it file log filter. Oops. Default button border draw item proc is probably the best name. And that the window here is, by the way, the one we got from get new dialog. And the number of the item we're being called for, so that means we can use it several times if we want to. Use the set dialog item to install this procedure. And get dialog item. Okay. We first... it's a bit confusing because the key bindings in Windows are different than they are in than they are in the emulator, of course. Okay, so get dialog item returns the item type, the display rectangle, and the control handle or application defined procedure of a given item in the dialog box. Get dialog item text returns the text of a given editable text or static text item. Oh, that's get dialog item text. Okay. Let's see, maybe they have an example for get dialog item. String. What? Okay, this will be interesting. Oh, here is a user item. Installing a draw procedure for an application-defined item. Nice. So inside Macintosh Toolbox Essentials really has an example for everything. So let's just do that, but not in Pascal. So we have the dialog, and now we say get dialog item. We should probably find this function here. Yeah. Whoops. Come on, don't scroll so fast. Luckily, text copying works in the emulator. So, okay. The window, main window is what it's called. By the way, for the purposes of this, this is really a dialog pointer, not just a window pointer. But since you don't have subclasses and superclasses in C, what they actually do in this classic macOS API is they're all defined as the same type. So there is a graph port, which is QuickDraw's data type for something you can draw in. And a window pointer is simply a graph point with a few fields added at the end that describe window-specific stuff, and a dialog pointer, again, is just a window record with a few things more added. But the dialog pointer type and the window pointer and the graph pointer data type are all just alternate names for graph pointers, really. And all the API basically assumes that the graph pointer you give it will actually be a valid dialog or window. So if you pass it something else, you don't get the type checking, it just crashes in spectacular ways. Okay, item number. What did we say? 4 was the item. Item type equals 0 for now. So let it return the item type. Handle item handle null for now. And rect item box. Let's just let that 0, 0, 0. I think that already works in this version of C. If not, then we'll get a compiler error. We'll see. Okay, get dialog item, and now set dialog item. Okay, main window, index of the item. Then we pass it its item type, I guess. We could just yeah, we pass it its item type. And now instead of the item type, we pass it the function pointer. Of course, we need to typecast it to handle, and that's the scariest about this entire API, basically, that there are so many spots in which you have to typecast between types. All right. That should be pretty much all we need. So now we'll copy this because we need to figure out where to draw for our item, right? So we take the window and the item number that we were passed, ask it for its item type, item handle, and item box. And now we say, what is it? Quick draw. Round rect.
Uh-oh.
Paint rect.
Uh-oh.
Oh, maybe we're not starting paint rect. Frame rect. That's what we're looking for. Okay. And paint rect is the fill version. So we say paint rect for the item box. We also need pen size. Yeah, pen size, width, height. Pen size 3, because remember we just wanted a 3 pixel rounded. Oh, we wanted a round rectangle. Frame round, yeah, frame round rect. And that has oval width and oval height as additional parameters. Let's see, I think 8.8 might be roughly right. Maybe we need a little more. I think 8.8 might be the actual outline of the buttons. But we'll see. So this should really be... Oh, should maybe play it safe and say set port the window to make sure we're drawing in the window. And now let's run this and see if it works. Okay, it didn't. Okay. I'm confused now. Oh, maybe it doesn't work at all because the user item... Ah, no. So now I click the say hello button, nothing happens yet. Quit button, it quits. So that part definitely works. It can distinguish. So we could do something like if item hit equals 2, then sysbeep. So we'll at least notice something. Maybe I need to do... Oh no, it's 3, isn't it? Because we had the icon right away.
Uh-oh.
Yeah.
Uh-oh.
So that works. So why is... Oh, I'm an idiot. We're PowerPC. So of course it doesn't work. We actually need the UPPs. Sorry, I'm an idiot. So so here's the thing. with the switch from 68,000 to PowerPC, you could mix PowerPC code and 68,000 code inside the same application. Because parts of the operating system, for example, were still written in 68,000 code. And also, you wanted to run old software, but that had to be able to call system functions that were already ported to PowerPC. And so what Apple did was they invented a universal procedure pointer, which is a little data structure. And that starts with a special sequence of numbers. And if the emulator is asked to run this sequence of numbers, then that's an invalid instruction for a 68,000 computer. And this particular number tells only the emulator, oh, this is actually PowerPC code. And then it exits the emulation and looks at whatever follows it and runs that as PowerPC code. So we need to find item UPP.
Uh-oh.
User item UPP. New user item proc. That's what we want. And so functions are basically global. So what you usually do is you define a global variable like user item UPP G default button border item proc equals new user item proc. Oh, and this will not work because this is not static. Okay, so do that here. And then we create this in main. And now we pass the UPP instead. So that basically creates a data structure around it. Because like all callbacks, like 68,000 code doesn't know about PowerPC existing, of course. That's why it needs to run in an emulator. And so it will just stuff its function pointers into data structures. And so whenever the system needs to call a callback function pointer, that, an application would fill out, it will basically start the 68K emulator and run it in that. Or rather, what it will do, it will call a special function, like here, call user item proc. A function like this, it's actually a macro that just call universal proc, so that does the actual work. But anyway, and this function first checks, is it native PowerPC code? Then just, jump over the native code indicator at the start and run the code behind it. If it's not, start the emulator and run it in emulation. So now this should work. Yes. And interestingly, they have compatibility code, those bastards. Ha! So you see, they noticed, someone drew a rounded rectangle around a push button in this window. So I guess they're trying to do the default outline, and it's around the default button. And so they just switched and drew this gray 3D outline. That's actually cool. So now just for you to see what it would do if macOS 9 didn't try to correct stuff to its fancy new look. Let's go in here and move this user item over there. And now we should get the regular rounded rectangle. Yes, as you see. And that isn't really the right diameter. As you see, that's more like this button. So I guess what we should do is 8, let's say 12 maybe? I can kind of recognize the right diameter when I see it. That could be close. I wonder if I move it over the other button. Let's see, maybe it will recognize that that's not the right outline. Yes. Okay, now we see it's at least 3 pixels too tall. So bottom 216. Okay, and I think let's try 12 looks pretty close, but I think it's 13 to get the right rounding. Yeah, that looks pretty good. So that's basically what you would do. You would create a user item that just draws this outline and place it on the quit button. And now, if we do that, the operating system will actually be, let's see, 3026. I think that should roughly be the right position for older macOS versions. But since the operating system just goes for the rough thing, we can't actually see it. I guess I could copy the quit button or something. Clever operating system. But anyway, so now you see how can we draw other things that don't exist as a system control inside a window. And so you can already see, like, there was a lot of manual work involved just in making a regular macOS 9 application run. But we're still using modal dialog, and that means we cannot click into the window. So how do we do that? let me just find my so there is a function called waitNextEvent, and that's really the important function. All right. So, and basically you would replace modal dialog with that. It's in events.h. Wait next event. It's too fast. Okay. So how do you use wait next event? Well, first you need some way of seeing, of having your loop not terminate. Usually you would use a Boolean, but since we want to do the... No, actually, let's use a Boolean. G keep running equals false, equals true, of course. So now we do while keep running. So yeah, usually you would make that a global variable. I'll do that in a second. So now, whoops, wrong button, yeah. Okay. So wait next event returns true when a new event arrives. You can also tell it which events you're interested in. I just say every event, which, gives us all the events. Then we want an event record. So that's just a data structure describing an event, kind of like NS event in modern systems. Sleep is like if nothing happens for a certain while, do we want to immediately be called back to get some more calculating time? Or, can we wait for a while or something? I'll just say 10/10ths of a second for now. And then there's the mouse region, which we'll deal with later, but basically it's a box that you can use to find out when the mouse has moved, for example, over a text field, and then it will send you a mouse moved event. But let's set that to null for now. All right. And now just so we can terminate, we say if event record, let's not call it, it's not even called event record. Let's call it current event. Current event what equals mouse down. Then say keep running equals false. Wish I could type. And one thing we want to do... Oh no, we can do that later. Okay, so let's just do this for now and see what happens. It won't look right because we haven't really written any code. Oh. Current event. You see, we get the window, but we don't get the contents. And as soon as we click, of course, everything goes away again. That's fine. So what's happened? Yeah, we haven't done anything. Like, modal dialog actually does a lot. So first, I think we want to draw something. So let's say switch current event what, and say case mouse down, case update event, I think is what it's called. Okay, let's see. Mouse down, mouse up, activate, update event is what it's called. Okay. And let's see, I have an example inside Macintosh Toolbox Essentials. So, by the way, if you want to start learning this yourself, the best thing you can do is find a PDF copy, for instance. I think Apple had them on their website for a while, of Inside Macintosh books, and in particular the book Macintosh Toolbox Essentials and the book Imaging with QuickDraw. Those two are kind of the most important things you need to get started writing, an actually useful application. And once you've done that, there's pretty much you can get any other book that seems to be, interesting. Like, there's more Macintosh Toolbox, which is fairly useful. Okay, now I found responding to update events. Yes. So what we say there is begin update, and we need the window. Oh, wait. Where is the code that actually makes it extract the window?
Addison Wesley Publishing Company, Reading, Massachusetts.
Sorry. It started reading the imprint of the book because I pushed the wrong button. Okay. Event message. Okay, again, like, the event record is a data structure that does a lot of work. And so you need to reinterpret a bunch of fields occasionally. Okay, window putter, current window equals current event dot message. That's where the documentation says it is kept. And then, so what begin update and end update do is, so macOS, when you need to draw a window, keeps track of which parts of a window need to be redrawn. So that means, for example, when I take the error and warnings window and move it over, then the area that gets exposed in the Stream app window, if you look now again, look exactly at this spot. It flashes white for a moment, only that right half, and then it fills in the contents again. And basically what begin update does is it clips the entire window to the newly exposed area, and that way you can just draw however you want, but it will only actually generate pixels for the parts that are visible here. And the rest will stay the same, and you get fairly little flashing. That of course means that your never mind. I completely got lost in my sentence there. What I meant to say was, and what end update basically does, is it restores the drawing area so you can draw in the entire window again, but it also empties the area that needs updating, because now it knows, okay, that has been drawn. So how do we actually draw a window's contents? So usually that would involve us doing manual drawing code for a lot of stuff, and us calling a function named draw controls to actually draw the push buttons and stuff. But since we're using a dialog here and not just a regular window, what we can actually do is, so we use get new dialog, we can actually ask the dialog manager to draw our window. And that will, for example, call the default button border item proc to draw our outline. So let's look at this, and I think it's called update dialog, yes. Or we could also just call draw dialog. Oh, we don't even need to do begin update and end update, it seems. I think update, oh no, wait, I may be mistaken here. Let me... Okay, they don't actually show the sample code. Okay, so let's just look at what update dialog actually does, because the documentation will probably... Okay, yeah. I'm doing the right thing. So if you look at update dialog, it needs to know the window. Current window is our dialog, and it needs the update region, and the update region is what begin update just used as the visible area. So we can just say the current window is what it's called, vis region, and that's the visible area of the window, which begin update just has made to match the rest. So if match the area that needs redrawing. So that should be all we need to actually get things to draw. Of course, we need a semicolon here. Yes, and as you see, we're one step further. We now have our icons and our buttons. We're just not reacting to the clicks yet. So this is one part of what modal dialog does. So now let's find let's find out how to handle a click in a dialog, which I've actually forgotten. I think it's dialog select. Because the documentation to the modal dialog function actually told me that modal dialog calls dialog select. So let's try that. Dialog select, current event, dialog ref, mouse down again. Let's put this variable at the top of the function because we will need it a couple of times. Okay. Copy this and set the variable to null because we're a very careful person who has been burned once too much. And now we don't need our own scope either. And now we do the same in mouse down. So let's find documentation for dialog select inside Macintosh, described on page 6139. So dialog select takes the event record, dialog record, returns an item number, and the dialog select function handles most of the events relating to a dialog box. If the event is an active or update event, activate or update event for a dialog box, dialog select activates or updates it and returns false. If the event involves an enabled item, dialog select returns a function result of true. Oh, okay, so we don't even need to do the update dialog ourselves if we don't want to. So I guess the idea is really that you do it like this. If not dialog oh, okay, now I know. So usually if you were running a modal dialog, oh, CodeWarrior had multiple undo. Oh, cool, thank you. So here's the thing. Usually you only have one modal dialog in the front, and then dialog select will tell you, you know, you can just say, is this an event for this dialog? And now we say, give us the item hit. And then we say if dialog select and item hit. And now if item hit equals 1, that's the quit button, then keep running equals false, else if item hit equals 3, then sysbeep 007. So that should hopefully work. Whoops, this button. Okay.
Uh-oh. Uh-oh.
Ooh, You see, it beeps and it quits. So actually we have a nice function dialog select that will do work for us. It will actually also be useful for this. Now I just saw, whoops, again, wrong keys. Is dialog event. If your application uses modeless dialog boxes, you need to appropriately handle events in them. You can choose to handle events for modeless dialog boxes using the same routines that you use to handle events in other windows. This is the approach used throughout this chapter. Alternatively, you can choose to call the isDialogEvent function in your event loop. To handle events in movable modal dialog boxes. Okay, what does this dialog? Because the thing is, I'm wondering, like, how does it decide? How am I supposed to decide which window to operate on? Like, because update events and mouse down events have a window. But for example, a suspend or resume window for the entire application has no window associated with it. So if I typecast current event message to a window pointer, I'll just get some random number, and if I pass that into dialog select as the current window, poof. Okay, let's see. To determine whether a modeless dialog box or a removable modal dialog box is active when an event occurs, you can use the isDialogEvent function. And that will just return true or false. Okay, I don't think it does any extra work. Test for mouse down events. Well, anyway, screw it. Check whether the event is a key down event. Yeah, okay, that's just the standard event proc work. Oh, but it probably, well, we're not handling key down right now. Well, let's just handle both at once. No, wait, let's not do that. Okay, so here's the thing. So we need to do a little bit of manual work because, of course, we know. So we haven't checked. I guess we should do isDialogEvent current event and dialog select. That way we don't actually try to run stuff wrong. And here as well, if this dialog event. Current window. Oh, current event. Because there can be windows from other processes or like system windows in our process. In theory. I think usually that's only a System 6 thing, and dialog select and is dialog event are actually System 7 and later. But who knows, it's safer if we don't assume every window is a dialog. Okay, so we're using that. And now else. One thing, like for the mouse down events, for instance, we actually have to figure out what else was clicked. For example, the menu bar has special handling. So I'll search for that. So we need to call a function named findWindow now. You see, like, this is getting to be some work. I mean, it would look less horrific if we actually structured our code. Like, I'm putting all of this into the same function. Usually you would probably go and say, you know, put this loop in its own place, put the window creation in its own place, and then here just case mouse down, call a mouse down handling function, case mouse up, call a mouse up handling function, and put this code in its own function. So let's see. We need events.h, and there we need find window. I always want to call it hit test for some reason. Oh no, that's not in events, that's probably in Windows. Yeah. I'm getting confused. I'm constantly like trying to do Control F3 or Control F in the emulator and Command F and Command G in Windows when looking at the documentation. All right, so hit part equals, let's see, we had the find window result cause. Okay. In desk is what it should default to. That just means nowhere, just on the desktop, you know. So hit part equals find window, and the point is in current event dot where, and it returns current window. Okay, and now we switch hit part, and now we can do case in menu bar. All right, what else do we want? in drag, we want that one, because that means moving windows, and right now we need to write that code ourselves. And I guess the close box and the zoom box later as well. Okay, and so how do we handle menu bar clicks? Well, that's fairly easy. Not menu chocky, but menu choice. We call menu select with current event where, and then switch menu choice oh, not XOR, bitwise and. So the high word of this long actually, wait, I should probably look up what exactly it returns, if it's a long or an unsigned long. Menus.h menu select. Yeah, it's just a long. So that is the ID of the menu. So that means case 129 would be the file menu. And then inside that, menu choice, we take the low word, and the first item will be the quit menu item that we should add in a moment. Okay, and now we find out drag window is the function. Okay, but what else do we need to do? If current window is not front window, then select window current window. So that brings a window to front when it's clicked. If we have multiple windows, that becomes relevant. And then let's find drag window. Current window, and the start position is current event where, and then we pass it the area in which it is allowed to drag something, and that's usually the so-called gray regions bounding box. And that is something funny. That's a handle that this function returns. A handle is basically a pointer to a pointer. So Macs didn't have memory management units. And so that means you only had the memory that was actually on the chips. You couldn't swap to disk or anything. And so they invented handles, which is basically when you create a new pointer, it gets entered into a table at the start of memory, the so-called master pointer table. And then they return you a pointer to the master pointer. And that's what you keep in all your data structures. And when the operating system finds out that, like memory is fragmented, so like at the start, there is, it's basically all full, and you want 20 bytes, and there are 10 bytes here and 10 bytes over there, but there's another memory block in the middle. Then what the operating system can do is can take this memory block in the middle, move it down, free up a continuous 20 bytes behind it. And it just does that by, moving the block and changing the master pointer. And so whatever code actually wanted to access the moved block still has its master pointer, so the next time it accesses it, it just gets a different address than before, and it's not surprised. And that's what they did to, work better with little memory. Region B box is, I think, what the bounding box is called. And I think we have to pass that as a pointer. Slightly unreadable, but this should work. And now, of course, I was smart. I made it a dialog window. So we need to change our resource now and make it from regular dialog. I guess for now, let's show it as a movable modal window. We'll probably later change it to a regular window when we implement the close box, but this way you've also seen that window style once. Let's see, did we mistype anything? No. Okay, and now, yes, you see, I can actually move the window around, and it gets redrawn in the right spot.
Uh-oh.
And it still reacts to clicks. Now, you've noticed we don't have any menus yet. So how do we do that? So what we need now is we need to define our menus first. So let's go back into the resource editor and, whoops, wrong button, Command K, create new resource, and we create an mbar resource, which stands for menu bar. Again, resource, insert new field, insert new field. So our Apple menu will be ID 128, our file menu will be 129, and our edit menu will be 130. We don't need to name it, but I just find it nicer if everything is named. Okay, now we create menus. The type of the resource is menu, surprisingly. So Apple menu, and there we do about stream app. All right. And then 129 file. And we give it, whoops, we add a quit item and give it Command Q. And then we create an edit menu. And that would be undo with Command Z, then a separator line, then cut. And you see, like, it's in Interface Builder, you could just drag out a complete menu bar with everything you need in it. But back in the old macOS, that was just what you did. You know, you created menus yourself. And I just crashed the emulator. Let's see how much is left. I guess while this is loading, I can check. Oh, get menu bar is not. I need get new menu bar. Get new M bar. Get new M bar. It's a bit inconsistent. So there are lots of calls that you can make to manually create each of your menus if you want. You don't need an mbar resource, but there is also a call get new mbar so that you can just use an mbar resource and define everything there, which is much more convenient. Okay, I found code. Okay, yeah, that's nice because it covers the memory management, the example code, which is always the difficult part in classic macOS. Let's see how this looks. The file needed minor repairs and is now okay. Oops. We can already see our menu bar is completely gone. It's draggable, of course. Okay, so let's create an mbar resource again. 128, 129, 130. Okay, Apple menu about stream app dot file quit command Q. Okay, it crashes again. But maybe I can slowly make progress. But we can do this. Let's see how much of the file is still there. Let's open the file directly. Okay. Every time I hit save, okay. Maybe it's hitting save in the editor. Weird. We shall see. I hope I can create the menus we need. It could be it previews the menu items in this editor, and maybe that's confusing it. Okay. Quit stream app. Maybe that helps. Okay. I saved after creating it. And now edit. Cut. Copy. Paste. Clear. X. C. V. Okay, this is getting dangerous. But we'll see. I don't remember ResEdit being that crashy, so that must be a new thing. Or like an emulator thing. I could probably... Like, the thing is, the emulator is a bit tougher on memory errors than a real computer was. So bugs that few people noticed because they were, you know, like writing somewhere at the end of memory or something, could still be there. Edit. Cut. Copy. Paste. Clear. X. C. V. Oh, I forgot to... All right. I mean, if I got the undo item, but I'm not actually sure whether... I think Dialog Manager supported one undo step, but don't take my word for it. I'm just glad that it didn't completely corrupt the system each time. It's when nothing is selected, I think. I just wanted to add a few items. Ha. Fascinating. So I have to be really careful how I do this, that I don't click. Let's see if selecting an item and adding a new one after it works. Undo. copy paste clear. Select all. X C Okay, folks, we're there. We have a full set of menus. I'm not even sure whether I'll get to implementing all of them. All right, let's find our code again. Okay, and now we need to load the menu bar, of course. So handle menu bar equals get new m bar 128. And again, instead of, the thing is, error checking is a lot more important here, because if my application crashes, it takes the entire emulator with it. They didn't have memory protection. So set menu bar, and then dispose handle, because you have to know whether get new m bar, what that actually gives you. And it gives you a handle that you're supposed to dispose, apparently. And now append res menu. This sounds a little weird. So what this does is, usually you can use this to return, to kind of make a menu with a list of resources. So for example, each font was a resource. So if you wanted a font menu, you just say append res menu font, and it would pick any fonts in your current application, any fonts in a loaded system extension, and any fonts built into the system. And similarly, the Apple menu used to contain little applications, calculator, for example, chooser. But those weren't real applications, those were drivers. And what driver in this case means is it's a bit of code that has multiple entry points. So it was a special kind of code plugin, and they actually got loaded into your application because macOS started out as a single tasking operating system. And that's why this is a drvr driver. But by now you see, like, there are actual applications and folders in there. So they just hard-coded it. If you create a menu called of driver resources, then we'll make that the Apple menu. And last but not least, we call draw menu bar. Okay. And this should now give us... Oh, right. I forgot. I'm in old-fashioned C. I can't just randomly declare new variables. They have to be at the start. All right. And now you see, we have a file menu, we have an edit menu, we have a help menu. The help menu, I didn't create that. We have an Apple menu, containing all the menu items. So we're good. We have everything. And now if I select quit stream map, it doesn't actually quit. Okay, so we have a bug there, but the quit button works. Good. So let's see. Case in menu bar. That's where we want to be. So let's see, can we enable the debugger? Let's see, can we debug? Can we set a breakpoint? Okay, we can't. Now the question is, did I mix up high and low bytes? Let's try high and low words. Let's see if that does anything. Yeah. Nope. Okay, easy to debug, even without a debugger, because what we can now do is we can actually show you something that you can do with this dialog. We can add a static text field. Show item numbers, that's what I wanted. And I even managed to click it. The resize box. Okay, so we have a static text field here. That's number 5. So now I have to find, what was it? Item text, I think, was the name of the function. That's menu. No. Come on. Get, here. Get dialog item text. Okay. So now we need to, now what I want to do is I want to print the number of the menu and item selected. So that's item 5. Get dialog item is what you do first, and then you say set dialog item text. All right, and that takes the item handle and a string. So debug string. And now we need a variable. So that's another special thing in macOS, classic macOS, since it came from Pascal, it uses Pascal strings. And that in turn means you use this type, str255. So C strings are a bunch of characters with a 0 byte at the end. Pascal strings, on the other hand, are 1 byte at the start that controls the length, and then that many characters after it. So str255 is actually a 256 byte block where the first byte is the length and all the other bytes are the contents, so that you have enough storage. And so now we need to do num to str, and then we say this number and debug string. Let's see if that works. Now I think debugster was in
Uh-oh.
No, it's not in. Oh, again we have a random selection somewhere.
Uh-oh.
Maximum memory. Maybe it was tool utils.
Uh-oh. Uh-oh.
Text utils. Yeah, num to string is what it is called. Okay. So num to string. So this should hopefully show us the first one. Oh, I know what I did it wrong. I need to bit shift here.
Uh-oh.
Oh, not this one, this one. Bit shift by 16. And that will probably just work now. Yeah, okay, I'm an idiot. That was the short answer. But anyway. Oh, the system actually implements the help menu for us. Oh, but we don't see... Okay, let's see if we can get it to actually... So we need to do set port. Current window. And then invalid, what is it called? So to tell the operating system to generate an update event. Inval.
Uh-oh.
Inval rect. Okay. Current window. Oh, wait. We can just use item box because we have it already. So this should be fine and should cause it to redraw. Yeah. Although we get a 0, which is a bit weird. Oh, probably because all of this is before we actually, because we want to print the menu choice, of course. We need to do it after we've actually assigned a value to it. Ha! Yeah, that might be it. Alright, let's just see if that works, because if it does, so that's of course without the bit shift. So let's bit shift that by 16, and then it should be at least readable for us humans. 128, 130, yes. And one thing, when you handle menu choices, what you actually need to do is you need to, it highlights the menu so it stays on while your application does something, and you need to unhighlight it once you're done. So highlight menu 0 is, I think, what it wants you to do. Yeah. All right. So we've made a little application. So far, we've demonstrated how to display a number in a dialog item. And you know, there are calls like append string and things like that. So you can build up longer text, or you can even use printf to build up text and then convert C to Pascal strings and then use set dialog item text. We've also shown how to use invalrect to actually cause it to only redraw the item whose text we just changed, which we need to do, otherwise the changed text won't be visible. We can move our window around. So yeah, we've done a whole bunch. We haven't done key events and stuff yet. I guess we should do that. Key down. I'm searching inside Macintosh again. I know you can't see that. Key down and auto key were usually the two you tried to handle. So to get the character, first we need to let's call it current character as well. Why change a good thing? Let's initialize to something halfway empty. And so we get the key press from the event message. So there are various mask constants. There is char code mask, which actually gives you an actual character code, so like the ASCII character pressed, basically, or, well, Mac Roman. There's also key code mask, which is like a physical number identifying the key on the keyboard. So, for example, if you were trying to do WASD for, you know, walking around in a game, you would usually use the key codes for W, A, S, and D. Because, for example, on a French keyboard, the W, A, S, D are in completely different places and are not in an upside-down T position. So you actually use completely different keys, but they're in the same physical position. Okay, current character, we have that. If it's a dialogue event, we just pass it to that one. Oh, dialogue select returns the window. I'm an idiot. I didn't see that. It's actually a reference parameter. So I don't actually need the one from the... So that statement is overwritten in that case. Okay, anyway. I think this should just work. But we first... We need to do else. Menu key. Current character. And again, we get a long menu choice from that. And now is the point where I finally have to tidy up my code a little, because we should move all of this code. Do menu choice. Do menu long menu choice. All right. And now we know why I originally said I wanted to make this a global variable, g keep running, because this way we can set it from that do menu function as well. And now we can do menu choice here as well. Okay. Let's see. Return doesn't do anything, so it doesn't do that automatically. Let's see. But Command Q worked. I guess Command Z was too slow. I should probably go default. What was it? Delay? Let's see, I think it's like this. So this should slow down things a little bit, unless it crashes. Yeah, you can now see when I hit Command C, edit highlights for a moment. So I've made these unhandled commands a little slower. So if I do Command A, that works. And you also see this takes a moment to unhighlight, but when I quit is handled, so that works fine. Alright, so that means we have now key down handling. Oh, of course, now what we need to do to show you actually is that dialogues are really clever. Because if I add an edit text item here, alright, that should be enough. So the cool thing is edit fields should work. Well, they sort of work. I guess it doesn't really like the background color, maybe? And apparently it intercepts our menu choices. So let's reverse that. Or no, maybe not. Well, no, it shouldn't. Wait, can it? Does it do cut, copy, paste? Oh yeah, it does. Does it do undo? No. Yeah, I can paste. Yeah, but certain key presses aren't really handled here. So I'm thinking we could probably call the standard dialog proc, but we've been going for a while, and I think this is a good point to stop. So you've seen it's a lot of work to just get an application working basically to a point where on modern macOS, all the code we've written so far, or 99.9% of the code we've written so far, was code that would just be there, would already be provided by the operating system the moment you click File, New Project. And that's why, like, everyone used a framework. Either they wrote it themselves, or they used Power Plant, or Think, class library, TCL, something like that, MacZoop. But so here, this is how the code looks, and that's not even finished. So that's code just for getting a dialog window with the right outline. But let's quickly, I think I'll do the dialog proc just because I've never done that and I'm curious whether it will work. So std, I think was std filter proc, yes. So let's do it for key down first. Is dialog event. Let's do that first. And then shift this in by 1. If dialog select. And now do std filter proc. Current window. Wait, that would have to be front window. Current event. Item head. And then if not this and dialog select, then react to it. I think that should be about right. Let's see what that does. Nope.
Uh-oh.
It's always a little... Oh no, wait. Really, the filter proc does it. So let's do this differently. If not standard filter proc, then do dialog select. And then
Uh-oh.
is that correct? Semicolon missing. And closing bracket missing. Let's see, maybe that does it. Or maybe I've misremembered. Maybe I've reversed it. No, it doesn't actually. I thought I could get by calling the standard filter proc directly. I hoped I could get it to do all the magic things like, you know, handle return as the OK button. But that doesn't work apparently. Okay, let's get rid of these, I guess. Well, let's say if I think dialog select has a return value, right? Yes. So we can say if not dialog select, then and current character equals \r, which is the return key. Then item hit equals 1, and we need to find the item. Where was it? All right. Key down. So that's how you usually would do the highlighting, is you get the dialog item for the default button, and that is a control handle, and then you do highlight control control handle item handle in button. So that's the constant that tells you it's the button body. And then highlight control 0 when you're done. And we need a call to delay. Delay, what is it? I think 8 or something. Should be enough. So the question is, will dialog select say it used it because it uses it for the text field? But maybe now we're not in the text field yet, I think. No, actually, I think it already claims it. Okay, so let's do that the other way around. Current, if the current character is return, then highlight control, else do this. That should work now, right? Or did I just forget a semicolon? Yes. Okay, now you might have seen that, you might have not. When I now press return again, it will highlight the quit button for a short moment and then trigger the quit action. So as you see, because it sets item hit to 1, we will end up in this case later, or dialog select should get called if we just click the button instead. What you can also do is react to the enter key, of course, and in that case it would actually let you implement multi-line text fields, because if you're in a multi-line text field, you could detect that, oh, that's the currently selected text item, and then pass through the return key. But basically, that's all the stuff that you have to do manually as well, if you don't use modal dialog. That's a lot of code, isn't it? And yeah, but I guess that's when we'll finish now. Thank you for watching this. I'm not sure if I'll go through more effort. We shall see. Have a great day.